Hello, fifth grade. It's Thursday, the 21st of May, 2020, and this is our science time. So we're looking at water vapor. We talked about that yesterday a little bit, that this was coming. We're going to read pages 211 to 213. Before we do so, I have sent a comp check to your parents. So make sure that you have that to help with your answers here. Let's look at what we're highlighting. So I'm looking at the comp check first so we can be listening for it as we read. Define dew point, condensation, and dew and frost. So four things there. Number 2, on what essential weather ingredient do all, like clouds, rain, and storms, depend? Number 3, which is able to hold more water vapor, warm air or cold air? Number 4, as air cools, what happens to its relative humidity? Number 5, what do we call the air that has reached 100% humidity? Number 6, can you explain why the bathroom mirror is fogged up after you take a shower? Number 7, on a hot, humid day, the windows of an air conditioning building will sometimes be covered over with a dewy layer of water. What causes the windows to fog up? Be sure to tell in your answer whether the water is on the inside or the outside of the windows, okay? It's important. All right, so let's get started. So listen for those things as we go, and you'll do a great job on your comp check. So page 211, it says, water vapor, the key to weather, right here. When you think about weather, you do not usually consider the rotation of the earth or the winds that circulate over the tropics. You are more interested in today's forecast for your area. How hot or cold is it going to be in LA today? Will it rain or snow? Is the sun going to shine today, or will the sky be cloudy? Will it be cold enough to wear a jacket? You want to know the forecast because local weather conditions can greatly affect many of your day-to-day activities. For example, a little bit of rain might determine whether or not you will be able to play outside after school. In the last section, we talked about the different seasons, temperatures, and winds that are found across the Earth's surface. These things make up weather's big picture. Now we are going to zoom in to take a close look at various types of weather as you could observe them from the ground in your own hometown. The smaller building blocks of weather include such things as clouds, rain, snow, and storms. They depend upon another essential ingredient of weather, water vapor. But before we can go on to learn about clouds and storms, we need to talk about how water vapor behaves when it is mixed with the air. Okay, so number 2 asked us, on what essential ingredient singular, do things like clouds, rain, and storms depend? And we just read that main ingredient is water vapor. Humidity. Humidity is relative. The air we breathe contains a small amount of water vapor. Depending on the temperature of the air, there is a limit to how much water vapor the air can hold. Warm air can hold much more water vapor than cold air can. We refer to the amount of water vapor in air as the humidity of the air. Humidity is measured by a percentage. If the humidity is 75%, for instance, that means that the air contains 75% of the water vapor it is able to hold at that temperature. Okay, so we know that all air has a little bit of water in it, all right? But there's difference. Humidity is relative, meaning that depending on different temperatures and whatnot, there could be different amounts of water vapor, different percentages, all right? And there, I should say, not depending on temperature too much, but the how much water the air can hold depends on the temperature of the air. So in other words, I'm going to read that again. It says, depending on the temperature of the air, there is a limit to how much water vapor the air can hold. So temperature is somewhat involved in that, obviously. So there's a limit to how much water vapor the air can hold depending on the temperature. So the temperature does have an aspect to it. Okay? So warm air can hold much more water vapor than cold air can. Okay, so temperature and water vapor basically go hand in hand. We refer to the amount of water vapor in air as a humidity of air. Humidity is measured by a percentage. I'm reading this again for a reason. If the humidity is 75%, for instance, that means that the air contains 75% of the water vapor it is able to hold at that temperature. Remember, water vapor and temperature, they work together. If the humidity of air is 100%, we say that the air is saturated. Saturated air is a particular temperature, at a particular temperature, contains the greatest amount of water vapor air can hold at that temperature. A humidity measurement tells us how full of water vapor the air is. Because warm and cold air are able to hold different amounts of water vapor, the humidity percentage is a relative measurement. That is, it is relative to or based upon the temperature of the air. It depends on that. We refer to the measurement of humidity as the relative humidity. Okay, I'm going to read that again. A humidity measurement tells us how full of water vapor the air is. Because the warm and cold air are able to hold different amounts of water vapor, the humidity percentage is a relative measurement. That is, it is relative to or based upon the temperature of the air. Okay? We refer to the measurement of humidity as a relative humidity. So it's based on the temperature of the air. All right? So for number 3, it says which is able to hold more water vapor, warm air or cold air. We read here that warm air, right here on the bottom of page 211, it's hard to tell with my light, warm air can hold much more water vapor than cold air. Okay, so we can answer that question. It says as air cools, what happens to its relative humidity? I want us to read a little bit more before we answer that. We're not quite there yet. It takes more water vapor to produce a humidity reading of 100% at a high temperature than it does to produce the same reading at a low temperature. For instance, saturated air at a temperature of 90 degrees Fahrenheit contains much more water vapor than the same amount of saturated air at a temperature of 30 degrees Fahrenheit. But both quantities of air have a relative humidity reading of 100% because they both hold as much water vapor as they possibly can at their different temperatures. Okay? I wanted to point out another answer here. Look at page 211. Here it says, if the humidity of air is 100%, we say that the air is saturated. So for number 5, it says, what do we call air that has reached 100% humidity? And we just read that it's considered saturated. Can't get any more air in there. It's at any more water vapor in there. It's at 100%. Okay, any more humidity in there. It's at 100%. I felt like there was something else I wanted to point out. I don't know. The dew point on page 212. It says, as air cools, it loses some of its ability to hold water vapor. Okay, so warmer air can hold more water vapor. Cooler air holds less water vapor, so it loses some of its ability to hold water vapor. Let's imagine we have a room full of very warm air at 45% relative humidity. If we cool the room down a few degrees, the relative humidity will rise, say to 60%. The amount of moisture in the air has not changed, but the total amount of water vapor the air can hold has been decreased. Okay? Why? Because the air got cooler. Cooler air holds less humidity, less water vapor than warmer air. All right? So if you look at number 4, it says as air cools, what happens to its relative humidity? Does it rise or does it cool? Let's read that again. It says as air cools, it loses some of its ability to hold water vapor. Let's imagine we have a room full of very warm air at 45% relative humidity. If we cool the room down a few degrees, the relative humidity will rise, say to around 60%. So, as air cools, number 4, let me start that again. As air cools, what happens to its relative humidity? We read that rises, okay? As air cools, the relative humidity rises as the temperature falls. The amount of moisture in the air has not changed, but the total amount of water vapor the air can hold has been decreased. Therefore, although at the warmer temperature the air was only 45% full of water vapor, at the cooler temperature the air is 60% full. If we continue to lower the temperature of the air in the room, the relative humidity of the air keeps on rising. Eventually, the relative humidity reaches 100% and the air has become saturated. The temperature at which cooling air becomes saturated is called the dew point. Okay? That's where you're going to see, like, on your grass in the morning, it's going to be wet. You're going to see dew. All right? As the air cools overnight. I want to double check one more thing. The humidity rises as the air cools, we talked about. So the dew point is not one fixed temperature. Rather, it varies depending on how much water vapor the cooling air contains. Air that contains a large amount of water vapor will have a higher dew point temperature than air that contains a very small amount of moisture. The air in the room started out with a relative humidity of 45%. Its dew point temperature is higher than it would have been if it had begun with a lower relative humidity of 30%. Okay, so we're going to look at this. We're going to unpack this by looking at the pictures they give us. That's the best way. It's a better way of explaining that than I can try to put into words for you. So let me turn this light so you can see my pictures a little better. You have these pictures in your book. So here, first we see warm air at 45% relative humidity, okay? Cooler air at 60% relative humidity. Cold air at 100% relative humidity, okay? Look up here. Warm air at 90 degrees Fahrenheit. It has a relative humidity of 100%. Cool air at 30 degrees Fahrenheit. It has a relative humidity of 100%. But look at how the molecules, where there are more or less in that picture and in that picture, okay? That basically represents your I'm trying to think of the best way to put it. Maybe it'll come to me. You probably have it already figured out, and I don't need to come up with the best way to put it for you. Condensation. So the main thing to remember about dew point is the temperature at which cooling air becomes saturated in that water vapor is called its dew point. Okay, and we know that, I want to read the beginning again. As the air cools, it loses some of its ability to hold water vapor. So it's at 45% relative humidity. The air starts to cool the room down, and as it cools the room down, the relative humidity will rise. Okay? That's the main thing we talked about in that section. And so when you're looking at those pictures, we see as the air is cooling, here we have 45% relative humidity. Then it's a little cooler, we have 60%. See how that's rising? The humidity rises as the air cools. Then we have 100%. The humidity rises even more as the air cools. You can tell the air is cooling. First it's like orange hot, then it's a little closer to being blue, and then blue would represent a colder color. Here, again, this is 90 degrees Fahrenheit with warm air, and you can see all that humidity, 100% humidity, and you can see all that activity, and then as it cools down, the relative humidity is still 100%, but we don't see as much activity as the air cools. Okay, so condensation. I think we answered, yeah, as air cools, number 4, what happens to its relative humidity? It rises. Condensation. Now you're going to find out why things fog up. It says, the dew point is the lowest possible temperature at which air is able to hold on to all of its water vapor. If saturated, air continues to cool below its dew point. It must release some of the vapor. Released water vapor leaves the air and changes back into liquid water in a process called condensation. I'm going to say that again. If saturated air continues to cool below its dew point, it's going to produce and release some of its vapor. Okay? When it does that, that released water vapor, it leaves the air and changes back into liquid water in a process called condensation. Okay? And condensation is like the fog on your mirror. You can't see the water vapor. You can see it in its dew point when the grass is wet in the morning. Okay? There's always some water around us. We talked about that. But when it gets so saturated, it has to release some of it. And that's when we see condensation, where we can actually see the grass is wet, we can touch it, feel it, etc. Our mirrors fog up. Let's read more. We see the results of condensation around us all the time. Have you ever sipped a tall glass of lemonade on a hot day? If so, you have probably noticed that the outside of the glass becomes very wet. Know that moisture is not lemonade oozing out of a crack in your glass. Okay? It's not the lemonade, it's condensation. The water vapor got so saturated that it has to release. And it goes from the coolness of your lemonade out to your glass. And that's why your glass gets slippery. It is pure water released through condensation when the hot, humid air surrounding the glass was suddenly chilled by coming into contact with the cold glass. Okay, like I said. So it's a warm day, humid day, let's say. You're drinking a glass of lemonade. As soon as you put the ice and you pour the lemonade into the glass, you walk outside on your front porch, the air is humid, the glass is feeling the humidity even before you put anything in it that's cold, and it will react. There will be a reaction when that cold, chilled lemonade or iced tea or whatever is surrounded by the humidity that encircled the glass. Okay? I'm going to read that again. When the hot, humid air surrounding the glass, like I said, surround the glass was suddenly chilled by coming into contact with the cold glass, the hot air cooled below its dew point, deposited its excess water vapor as a liquid onto your glass. Riding in the car with your family on a cold night, you may wonder why the windows are all fogged up. Again, the cause is condensation. Why? The cold air, the inside of the warmer car. Again, the cause is condensation. The breath of the people in the car, like I said, the car is warmer, body heat, breath of the people, makes the air inside much more warm and moist than the air outside the car. Once again, there's a reaction to the heat and the moisture, and the coolness, I should say. When the humid inside air is cooled below its dew point through contact with the cold glass, the result is a thin, misty layer of water on the inside of the window. Okay? So you get into it's cold at night, it's a cool night, you get into your car, you shut the doors, immediately the car will start to fog up. You'll need to use your defroster because your warm bodies The warmth from your body, radiating from your body, your breath as you speak, as you breathe, has a reaction with that cold air, and that causes fog. Okay? So I'm going to read that again. Riding in the car with your family on a cold night, you may wonder why the windows are all fogged up. Again, the cause is condensation. The breath of the people in the car makes the air inside much more warm and moist than the air outside the car. When the humid inside air is cooled below its dew point through contact with the cold glass, the result is a thin, misty layer of water on the inside of the window. Okay? During the day, the Earth's surface absorbs heat from the sun. Then at night, the Earth radiates its heat back into the atmosphere. As the ground gives off heat, it cools faster than the air above it, and the temperature of the ground drops quite a bit lower than the temperature of the air. The warmer air just above the ground is cooled by contact with the cold ground. What do you suppose happens when this air is cooled below its dew point? You can guess easily enough. Dew forms on the ground as the water vapor in the air condenses. Like I said, you're going to get the dew like on the grass. If the temperature of the ground is below freezing, the water vapor freezes, forming frost on the ground instead of dew. So, again, when cooling air becomes saturated, it becomes to a dew point. And as a result of that, we just read the warmer air just above the ground is cooled by contact with the cold ground. What do you suppose happens when this air is cooled below its dew point? Okay, remember, dew point, when it gets cooled below, when it gets saturated, the cooling air gets saturated. It's its dew point. So when it's cooled below that, and it gets to that level where it is its dew point, when that happens, dew forms. So I gave you an example of dew forming before we read about it. I talked about you can see it on the grass and whatnot. So I just want you to know that we have to hit the dew point first before the dew can form. Okay? So look at number 6. Can you explain why the bathroom mirror is fogged up after you take a shower? Okay? Think about the cold surface of the mirror is going to have a reaction just like the cool ice and lemonade in the glass, the cool windshield, and then the heat of your bodies and your breath, breathing, talking, hits it. Same scenario. The glass is cool. You turn on the warm air from the shower. The steam, okay, will fog up the cool mirror. All right? There's a reaction. Again, humid air, warm outside, pour my lemonade with my ice into my glass, will form the water vapor around the glass. Cold night, I get in the car, the heat from my breath, talking, my body heat, my whole family's in the car, hits the windshield, that was cold glass, there's a reaction, it fogs up. The same in the tub. The cold mirror, the mirror's cool, I come in, I turn the shower on, the humidity, there's a reaction between the cold mirror and the humidity fogs up the mirror, okay? So I think you can put that pretty easily in your own words. I just gave you a good example. So that warm air condenses, right? And it will reveal itself, so to speak, on that cold mirror. And it will be foggy. You can write something on it with your finger. Okay? Same in like the windows of your car. All right? And then it says here for number 7, on a hot, humid day, the windows of an air conditioning building will sometimes be covered over with a dewy layer of water. What causes the windows to fog up? Be sure to tell in your answer whether the water is on the inside or the outside of the windows. Same principle, okay? So it says that you're in an air conditioning building. So is it hot or cold in that air conditioning building? It's very cold, okay? And the building has been sitting in cold air. Let's say it's a school building and we've been in school from 8:30 to 3, air conditioning going full blast the whole time. It's really cool in that building, all right? So the windows on the building are really cold from the inside air. The outside air is warm, or we wouldn't have the air conditioning on. The inside air is cool, so it's really cool. So when when the hot, humid air outside comes into contact with the cool glass, let's say I open the door or something, or I open the window, that hot air comes in and collides, so to speak, with that cooler air that's on the glass from being in the air conditioning all day. The air cools below its dew point, okay? It happens suddenly, it goes below its dew point, and then we know that condensation occurs on the outside of the windows, okay? Because it's a warmth from the outside that when it hits the cool air, the warmth is what causes the reaction. Just like the warmth from your breath causes the fog on your windshield. The warmth from the outside causes the water vapor, the outside of your glass, to be wet when you're drinking your lemonade. Okay? So it's not complicated. It's just something that we don't think about a lot. So I've walked you through the comp check. I've done that on purpose because I know it can be kind of complicated. You can read it over and over. You can listen to this video over and over if that's helpful to you. The key terms again: humidity is relative, depends on temperature. Warm air can hold much more water vapor than cold air can. I'm reading all the bold print. The amount of water vapor in the air is called humidity. If the humidity in the air is 100%, it's saturated. The measurement of humidity is called relative humidity because it depends on the temperature. We talked about that. The dew point is the temperature at which cooling air becomes saturated. That's called its dew point. The cooling air hits warm air. It gets to a level called the dew point, and there's a reaction. You see the fog. You see the condensation, in other words. Condensation is released water vapor when it leaves the air and changes back into liquid water. It's a process called condensation, like the dew on the grass. And dew forms on the ground as the water vapor in the air condenses, gets tighter, smaller. And then if the ground is below freezing, because we know the ground is cold, remember warm air rises, so the cool air comes down, fills in those low pressure areas. We talked about that. So if it's so cold as the water vapor settles on your sidewalk, you're going to get some frost or on your grass. We don't get that a lot in LA. I remember being a kid and there was frost on the grass a handful of times, and I thought that was the coolest thing ever. You can't make snowballs with it or anything, but you can feel it. So that should be thorough and help you. And I've gone over each answer, so you should do well on that. All right, make sure you use your template, please.